Okay, now this, and we move the table back and over so I have enough room to maneuver around things. Good idea, please. You're thinking. You're thinking. All right. Put the shield up. Put the computer back. So the CNC and the table without the water, seems like with the water, it was coming in around 800 pounds, and the water is about 250. 8 gallons, 28 gallons of water at 8 pounds a gallon.
Right.
If it was 30 gallons, it'd be 240. So let's just say the water weighs 240. So 750, 250, yes, so it's about 500 pounds with the CNC machine and the table without the water. Close enough. Because I got stuff underneath there. Plus we got that steel. We got 100 pounds of that welding top sitting underneath the table. It's on the table in a shelf underneath it. Okay. Now, let's go ahead and mount the strain relief, the angler. We'll call that the angler strain relief, huh? A little fishing theme there.
Yeah.
The bLouChip angler strain relief.
It stings, Louis.
How about that? All right. I need power on the power supply. Need to take the clamps off from lifting. Forgot to do that one time. That wasn't pretty. Here, right here. Oh, that one was already off. This one was on. See, when it's pushed all the way over here, I only need to use one.
Mm-hmm.
When the router was on it, I had to park it here. Then I needed to capture it with two. So what we're doing is we're taking these little Harbor Freight clamps off, and what we do is we pinch the pinion gear with these. So the pinion gear would be right here. Well, you can't see that, can you? Huh. Where can you see that? You can see it right here. So the pinion gear would be right here. So we're putting these around the pinion gear to capture it on the rack, and then it won't move during the lift, in theory. And it hasn't.
So you're hooked up here, power's
All right,
on.
I'm going to double check the hose connection
Yeah,
here,
check it
since
out.
that's a critical connection.
I know. Figured that.
Yeah. So I got something loose here, Blaze. Oh, what happens, Blaze?
What's loose?
Well, so this hose connection, so let's tell the people what we're doing here. So this, I don't think I walked you through this. The washer must be stuck on there. It is. All right. So this is a double female garden hose connection, brass connection. So these two pieces, they rotate. This is a ball valve, no pressure, okay? This is a ball valve for a garden hose with a 3/4, oh no, I'm sorry, it's garden hose on both ends. So is this, yeah. The 3/4 NPT is the drain on the pan, and that has a hose garden bib on it with a ball valve. But it's 3/4 flush mount on the inside, and it's tapped on the inside, female threads on the inside, so I could put a 3/4 nipple coming off the top, which you'll see in a minute. I'll just put it on now. I screw that in a couple of turns, doesn't have to be tight. Couple of turns. Hold that one second. We're switching gears here. We're on top of the table now, of course. I got another one with an elbow, 3/4 NPT, and I screw it in to that elbow. I guess you can see that. And I let that sit right there like that. And if I set it right on top of one of these slats, it diverts the water enough that keeps the splash down. But anyway, this is going to be the fill when we turn the hose on, and it's pointing down. We can run it full throttle and fills faster. So what happened was when you tightened that onto here, it loosened this one.
I got you. Okay.
So you got to just watch for that. So I put the one on the table first. I get it tight.
The top one is tight.
Top one is tight, but now when I tighten the bottom one, you got to be aware that tighten.
Okay.
You're actually turning the bottom one in a way that would loosen the top if it grabs.
I got you.
So you just got to double check it. Otherwise, we'd have a mess.
Was I certified on this?
Well, you are now.
I am. Okay.
If you want to
Oh, I know exactly what
make
you're
a
doing.
note of that.
Yep. It's in the vault.
Yeah, it's in the vault. Okay, so get this nice and tight. Make sure the top one stays tight. Because this thing will leak. I mean, with this pressure, jeez, this thing leaks easily. All right, now we got it.
When I hook up the one with the yellow label on
The
it?
yellow flag, yes sir.
Got it.
And go ahead, and I'm ready for pressure. I'm closed off here. Eventually, I'm mounting this fan up on the wall permanently with a louver to blow the air right out top of the wall there. Are we pressurized?
Ready, Lloyd?
Yeah, I'm ready. Go ahead. I got nothing yet. Okay, you opened up both of them. Okay. Well, the other one's running too. The other one must have been open already. Okay. All right, so now there's a bunch of air in this hose. So we have to purge the air, and that's a bit of a slower process. Or it belches water all over the place. All right, hold on. I forgot something, Blaze. I knew there was something else I had to do. We got to put the spacer in and raise the pan before I get the water in there. Or that, we'd have to drain it. So, got to break it loose on the corners. Set it up on a wedge. So what we're doing here is we're raising the pan.
Same on this end?
Well, you got to use a tool to raise it. So right at the corner, just now you got to go right on the corner because there's a reinforcement on the corner. It doesn't punch a hole in the pan. That's all you need. Just put the wedge in there.
Right in here?
Yep.
Okay.
And then the other side's the same way. We got to kind of walk it up. Here, let me- Get it in there. All right, now I can get a better bite. Okay, hold on. I'm going to lift it from another spot. Okay, now let me get this one all back here. So we just got to walk this pan up in this opening, because when I made the pan, I made it a little tight. Next pan I make, not going to be as tight. It's going to go up a lot easier. So I get the pan relatively level with the top of the frame, which is its final spot. And then I'll put the spacer in. Mine went too high. All right, so here, put this one here, Blaze. So you're going to pull that out in just a moment.
All right.
Not yet. Put one back here. Okay.
Pull it?
No, not yet. I got to get the spacer. Okay. Now the spacer. So this is the spacer grid. This is cut out so that it goes through the drain and fill neck that's in the back right corner. So this goes on, gets inserted here under the pan, and it rides on the table grid for the pan, and it's raising the pan up to the level of the frame. It's a 1-inch spacer, that's 1-inch frame.
I took the
Okay. All right, would you mind?
in the other one?
Yeah, can you reach that one?
Yeah.
It's a reach.
No, it's still tight.
All right, how
I
about
got
that?
it. Okay.
All right. So a 1-inch spacer slides in. Again, it's tight because the pan is snug in the opening.
All right, taking these two out.
Yeah, you can take them. There we go. All right, now, sometimes it'll hang up on that leg, so just, yeah, which leg's it hung on?
That's there.
No, it's
No,
not, it's
no.
hitting the leg.
On this side.
I got it.
You got it.
There we go, right there. So there you go. Now the pan is solid, carries weight. Now, I do want to, where'd you put those, I need the wedges. I need 2 of them. You need 2 of them, I need 2 of them. All right, so what I do now is, I'm going to shim up, I guess, the pan so that it's right at the top. So you can beat on these corners, Blaze, because that's an 1/8-inch corner.
Yeah, well, these are lower.
Yeah, so I'm just saying, if you're going to beat on something, you got to beat on that 1/8-inch plate that's in the corner.
Okay.
And the same way when you lift, if you can put this on the 1/8-inch plate, then we're not going to punch a hole in the pan. That's pretty close. I'd like to be a little lower, so I'll put that in loose. This side got to come up just a skosh. This side. Now, I'll say the wedges are by design because, you know, when you're bending sheet metal, and you want to get it exact and, you know, all that, I wanted to leave a little room for adjustment like this. And so that's not a problem. That pan, we made the pan here in the shop. Then I'll know when the damn thing is up there, and I'll have to keep bending over. Tighten it. Right there, it's right there.
Right?
I want to put it in from here so it doesn't interfere. That'll be part of the new process there. You know? There we go. Here, bring it over here. This corner here was fighting me. Lay it on that corner. It's high, isn't it?
Yeah, it's a hair.
Whack it. Okay. I saw it move, so we're good. There we go. Now, the slats are probably, you know, they could be 20 thousandths out of whack too, but hey, that's why you have a torch height adjustment.
Yes, your question.
Torch height controller.
If you put,
Here, let me see it. Let's get this one too. Yeah, this is, should have been doing this for a long
it
time.
would be beneficial if you make it
I'm
permanent.
gonna keep this piece right
I
here,
understand that. You know
so
what I'm- you know what
it's
I'm
ready
saying?
the next time we need to do that. What?
If you weld a piece in here,
Well, no, you can't do that. Because this has gotta be open. The whole thing's gotta be open.
okay?
Yeah.
Thought just enough to
Yeah,
gauge it.
I mean, it has merit. Let me think about that. That's not part of the cutting area, so it has merit.
Won't be interfering.
You know, the cutting area is about right here, so
You know exactly where the level is.
you would.
Feel for thought.
Oh, well, wait a minute, here's the
Oh,
problem.
okay.
Okay, the MDF sets on here. Then that would be shimming up the MDF.
Okay.
Yeah. I want the MDF to have contact all the way around. I knew there was a reason I didn't do that. So, hey, how we doing on time? We gotta be over 30.
Just a bit, yeah.
Golly, tell you what. All right, let me get this water back on. Man, cannot hold to a schedule, tell you. Let's see. All right, there. I think we still have a little air to purge. There it is. You gotta let it run slow here until that air pops out. Otherwise it'll make a mess. All right, we're gonna let's use 12 gauge to make these parts. I think I got enough 12 gauge scrap.
They're out here.
No, well, I don't know, I might have some out there. I know I got some here somewhere. All right, I think all the air is out. I think it is. Should be out by now, it's only a 50-foot hose. Heck, it's a
I
20.
think it's running good.
It's 50 foot? Yeah, it's 50 foot. There. Now she's wide open. So that'll fill.
I got a confirmation from
What
the
minute?
number 7.
Yeah?
Yeah.
You asked him, huh?
And that's right.
Telling you.
His
That is dangerous.
His response was, of course.
We're making a gift for somebody. And my policy is if it's a gift, we get to decide what's on it, within reason. Now, we understand what they want as a gift, but the finer details, that's up to us. Otherwise, it's an endless.
That's what breaks us away from bLouChip.
Exactly. What do you mean?
That makes it special.
Well, that is
That's our
bLouChip.
signature.
That is bLouChip.
That's
Our
signature.
signature is customizing it
That's right.
when it's a gift.
That's my point.
When the customer's paying for it, then they own all the specifications.
I hope only family is watching this video.
But when it's a gift, we got a general specification,
I made one change.
unless it's a surprise.
I made one change in the drawing.
Okay.
It had it 7 sideways.
Well, I have the 7 so that when you walk up to the steps, you'll see it.
No, I need to do this one.
Okay. Either way, you're in charge of that. He's your friend. He's a bLouChip friend now. He's a friend of
He
bLouChip.
belongs to the fraternity.
That's right. Okay, we're just waiting on the water because I have learned that if I try to do something else while this fills, it'll overflow. Don't do anything else while you're flowing water in the shop with electrical stuff all over the place. So the 7's going to work. Did you tell him about the New York Yankee?
No, it's surprising.
Okay. Well, he knows about the 7, though.
Yeah, you know.
So the theme is out.
Well, I only asked him what his favorite.
Oh, the favorite player?
That's all it is.
Mantle. Mickey Mantle. The Mick.
Thanks for you and Nick.
Was it Mantle was the St. Louis player too for a while? Wasn't
No.
he? Which one was?
Usual. Stan Musial.
Stan. Well, no. I'm thinking of Roger Maris. Roger
Maris played out there.
He
played
crossed over.
He played for Kansas City.
Wasn't he a Yankee at one point?
Yeah, Roger Maris broke the record, the home run record. He played for Kansas City and they traded for him.
But he's never a Yankee.
Yes, he was.
Oh, okay. Then he went to St. Louis. Roger Maris was St. Louis, I'm pretty sure. Oh, wait a minute. I'm getting close here. Let me shut that. Okay, we can cut the water off out there.
That's right. Okay.
So, hey Blaze.
Yeah.
Put the handle down first so that the water bleeds out of the hose, and then shut the ball valve.
Okay.
I think you got it. I'm standing on it. No pressure. All right, so the ball valves are off. Oh, do you know what the other thing I do? I disconnect the hose so that some unknowing person that might walk up to use the other hose, they don't blast water into my shop.
No names mentioned.
No names.
Okay, I got you.
But the yellow tagged line disconnected. And hang on that hook, please. Can never have enough safety precautions. Things still go wrong. All right. Tell you what, I got that water level up there. We might have a world record water height on here.
That looks pretty.
Well, it's not a world record because the world record would be over the top, but next to a world record. But that's the highest point right there. The rest of it's about a 1/16 of an inch lower, so we're good. I think we're all right. We're not going to be cutting back there. All right, so now we need 12 gauge. So first, let's get our. This is our operation shelf when I'm doing firing. It sits into the cutting area, but I don't cut there when I'm using it, obviously. But I like it because it's not out here where I tend to walk. So I use this area as long as I can get away with it. Now we don't need that one because that's our backup. So I use this one when my steel gets to the point where I got to narrow that one.
Okay.
And then this one I usually put on top of the steel, because if the steel's out there, I'm cutting it. So it'll have a hole in it. So I just keep that one to, when I got to service the torch, it's there to set on top. All right. I'm going to go ahead and, it's already powered up, okay? Plugged in, powered up. The motor drivers aren't on because I've been moving the gantry. So the next thing I do is I'm going to be homing the machine. So when I home the machine, before I turn the drivers on, I like to get it near the home position so I'm not waiting. So, well, until we get the torch on, we can't say that we're converted. So let me get the torch on and then we can say we're converted. What's our time on that video? Can you look at that screen? I bet we're 45 minutes.
39.
39. Okay, we're going to make 45. All right, I'm going to power up the drivers. Motor drivers are on. I'm going to power up the controller by plugging in my USB. Controller's on. Launching UGS, Universal G-Code Sender. Now, I don't know if the camera, I could probably see that. If I kind of work like that, you could probably see it. So, UGS is up. I'm going to connect. And now I'm going to home the machine. I'll home it and then I'll bring it up here to my tool change position and put the torch on. Torches are magnetically attached, so it breaks away if it hits, has a collision with anything on the table. A significant collision. All right, coming up. Meaning it can tolerate, the magnetic attach mechanism and the bracketing can tolerate minor dross interference and a minor scrape onto the surface. The torch tip gets too low. It shouldn't, but it happens. Okay, I'm grabbing the torch here, Blaze. Going to the clean room. The Model T clean room. Yeah, that was about as clunky a time as I ever got that out of there. Of course, we're videotaping. All right, can you move this up where near the door where it's going to go when we use it? There you go. Thank you. All right, just pulling this out. So I have my torch lead coiled here in such a way that if I put it on correctly, this holder here, I drape it here, that life is good. So, push that back now. Now I just need to, this is a heavily jacketed torch lead. I thought, I posted in the MillRight forum that it was shielded. I've since had the torch head disassembled for some servicing and discovered it's not shielded. It's not coaxial. So I also discovered from George's Plasma, that this is not a Tecmo torch. It's close. It's a Tecmo behave like, but not Tecmo. Tecmo sells a shielded torch lead, but it's more than likely it's a Tecmo head. This torch was probably custom made for PrimeWeld. I believe they sell Tecmos now, but this was during COVID when I got it, and they didn't tell me it was Tecmo, so I'm not claiming that. I just assumed it was because this cable lead says plasma, plasma, plasma all the way up and down it. George tells me that Lincoln had a bunch of that cable made for one of their torches. And he said it's probably leftover stock from that somebody used that made this torch. So anyway, I digress. All right, now, I got you probably saw two ports up here, two 4-pin aircraft ports. One is for plasma, the other one is for laser. plug this into the plasma port. If there's ever any question, Blaze, ask. But that's the plasma's labeled in the back.
Okay, you got them labeled?
Now, here's a little, aha, there it is. So, little side effect of the Delrin wheels that, or the V wheels, let's just call them V wheels. I don't know if it's Delrin, looks like it, feels like it, but the V wheels that are popularly used on CNC machines, there's bigger ones here. They'll get flat spots on them. If you got them adjusted, even if they're correct, which is just a slight amount of tension, they'll get flat spots when they sit in one spot for a few days. So these have flat spots that when that flat spot is it's not catching it now, but it was. So what I do is I grab the wheels with my fingers. Not grab them, but I put pressure with my fingers on the wheel. And this is actually how you check the tension. And you ought to be able to move them. They ought to be able to rotate, just barely. So I rotate them a little bit, all four of them, and they're out of sync now. The flat spots are out of sync. So just one flat spot isn't enough to cause it to hesitate. But all four flat spots hitting the groove at the same time will cause it to stick. But we're good. This switch here that's making is the probe switch. This is the switch that is made when I touch off to the metal to know that I'm zero.
So the temporary flat spot that you're talking about.
Right.
When you rotate it.
The flat spot's still there.
Will it always be there, or does it work its way out?
It'll work its way out.
Okay.
As the more, and it's probably already worked its way out because we just did some plasma cutting about a week ago.
Okay.
But if it's sat for a couple of weeks, it wouldn't have worked their way out that quick.
Oh, really? Okay.
But by rotating them, you get them out of sync. So any one of four flat spots won't cause it to stick. You see what I'm saying?
Mm-hmm.
But all four of them in sync with each other, hitting at the same time, will cause it to stick. Yeah. And usually it's going to stick wherever it was relaxed. And these springs, when this is not hanging by gravity, these springs push the carriage up. So the flat spot on this is usually at this up position. And that's where it was when I first started moving it, but it's not there now. And what that does is it gets so that's where the micro switch is.
Mm-hmm.
So it'll fall into that flat spot and go beyond the switch. You see what I'm saying? Yeah. And then it gives me an incorrect reading. So the springs are a bLouChip add-on. That takes a little weight off of here. So that I'm not, if the steel would deflect, if I'm cutting a really thin gauge, would deflect from the weight of the torch when I'm zeroing it, it minimizes that deflection. But on the other hand, if it's deflecting, that's not good. So you try to set it up so there's no deflection, but sometimes you just can't get rid of it. So the springs are there to minimize the weight of the torch onto the steel, to minimize deflection. This is the breakaway switch. So here's the magnetic mount. You can see I just broke it away like that, and it's got a little bit more resistance to rotational torque. So a rotating breakaway, if it's hitting side to side, which would be more of a rotating, a little more resistance than not, and that's because I've got these 3/16 guide bars here that handle my alignment. Make sure that's free of any debris. Magnets are back here. Make sure they're free of debris. I got two little pads here that extend the width of the magnet mount. Again, to make it necessary, you need more torque to break it away. So all of that adds to its resistance to interference, which you don't want it to be 100%, of course, because you want it to break away, but you don't want the torch to break. When I say breakaway, I mean this, right? And when that happens, this switch is a safety interrupt to the microcontroller. It cuts off the torch, the movement, everything when that happens. There's two circuits that do that: pause and safety door on the Adreno board. And I'm using safety door because safety door will kill the torch. Pause. If you're in laser mode, it'll kill the torch, which I am. But if you're not in laser mode, pause does not kill the spindle. And that's by design. So every time I break away, I have to hit the resume button. I got pause and resume buttons here and over here, and they should be safety door and resume buttons, because that's what it is, same circuit. Okay, so now we've done the conversion. So out of all that talking and all that, it's a 30-minute conversion, because I was talking for 15 minutes. So that's the extent of it. But let's throw the steel on, and we'll use the bLouChip crab leg clamp.
Okay.
So stay tuned. We got more. Oh, I didn't finish this either. All right. So I got to put this on the hook here and drape it right here. And then I have to hook up the other end of the torch to the plasma cutter. So I'm just got the stand hooked up and everything, huh? All right, you said you spotted some 12 gauge out here?
I thought you had some from the last job.
Well, there might be some here. Grabbing that one. Oh, yeah, there is. Hey, bingo. All right, that's a winner. All right. Perfect. Okay. Let's put this in this way. Make sure this is... Okay, we're going to put the crown side up. Slightly thinner. All right, now put the spacer in. I got a 1-inch square bar here that I'm going to put in as a spacer right up against. So this board is square, not board. This shelf is square. This aluminum, and it's up against my frame. Gantry is square to the frame, and I got the spacer in to keep it away from my shelf, and I'm going to pull it. Let's set it up so that the edge is near a slat, so we minimize that deflection. There we go. Okay, now, all right, let me get this out of here. All right, now, let's put a clamp on that, please. Okay. Got a little bit right there, but it was crowned. So what I can do, go to the crab leg. Now, is that the modified crab? Yeah, okay. So let's just show this to the viewership here. So we have here a bLouChip original, the crab leg, the bLouChip crab leg clamp. What we got here is a little spike at the end here to make contact. We got a bowed piece of metal here that slides in and out adjustment to give me an adjustable tension. And I can slide this in and out of this tube as an extension. So I know that that's A little past halfway is a pretty good amount of tension that we want. So we got a sliding foot here that we then clamp to the frame. So you reach in, you put this anywhere you want. You reach in. Obviously, I'm going to stay out of my torch path. So I'm going to shoot for the middle here. And I'm going to give myself a little more bow. And let's extend that a little more for a little more tension. Actually, you know what, Blaze? Did I go back there? No, we'll do it here.
Back on this side?
Yeah, I was thinking, but let's just do it right here. Because the more length I got, the more tension I can apply. Well, I can apply tension no matter what the length is, but I got more places along the path of the clamp that can apply tension, let's put it that way. There. Now, solid there. I still got a little bit there, but not nearly what it was. And now I also have an electrical connection if I needed it, which I don't because I'm extending off the table. But if I wasn't, I got an electrical connection, not just applying tension. All right, so now I need more tension. Need more tension. So let's slide that out, push that in.
Better. Yeah. What do you think?
Well, it's definitely better. And over here where we're cutting, it's solid.
Okay.
I got a little lift right there, but we'll be all right. I won't do any piercing right there. I'll zero it on this corner, but my pierces will be away from there because I'm solid on the rest of it. Okay. So that's that. That's the use of the bLouChip crab leg. All right, now. That's it. The rest of it I think we've already got movies on. Because I'm just going to check the torch, clean the tip, set the right tip in. I got to draw it up, but we got the sketch. So I think we're good.